or that's the record. So welcome. I want to welcome you all. So before we start, just a quick one. Have we been able to? Were we able to go through any of those to generate any data or any of the data set that we say we're going to look through?
We have not.
Hello, can you mute yourself and talk, please? Mr. Clem already told me, so he wasn't able to because of certain uh, because of some stuff that he wasn't able to come up with it. So what about Mr. Young One and Madam Ifi?
If we have not been able to do.
Okay. So since all of you are on the same page, so after now, I'm going to drop
Telling you, we're
a
even on
data
call.
set. Yeah, I know. I'm going to drop a data set on the WhatsApp group. So you guys can use that to can play around with that particular one. So I hope that will be okay then.
Yeah.
All right. So basically, we'll go through uh, that aspect that Mr. Clem was, since you, a whole lot of you actually had some few challenge. Well, what we are going to do, we are going to, this class may not be as long as that because since a lot of you are actually busy and some has some things they need to rest and do some things too. So we'll just have probably maybe we'll close the session by 8. Then we'll reconvene tomorrow. Hopefully, I hope all of us will be much better tomorrow too. So and bearing in mind that we are supposed to finish up God's willing by Saturday. So I'm going to share my screen now. So we're going to go through that aspect that there were since there was issue as regard to how we went about it. So I'm going to share my screen then to just take us through that process once again, trusting that we will get it this time. So I guess should see my screen now.
Yeah.
Okay. So just allow the software to load. But basically all what we've done so far, I guess we are getting along with it. Except the one that you guys were complaining that it was not really, you didn't get sorry. So I'm going to open up the data we've been using. We use for that specific training. That data, let me hide this. So let me look for that data.
Sure.
Okay. I think it should be. Okay, let's just go and get it from the where we saved it. So My data is on the, yeah, I think, okay. So that's it. So this was the data, and all of us, we got it to this point on how we did the transformation and all of that. Basically, where the issue was how did we run the uh, crossbar? But I told us initially that before you run, even before you run the crossbar, the first thing you are supposed to do is to run a frequency on it. You will still remember that you run a frequency to be
By that you
sure.
mean normality, right?
So how did you do? No, not normality. That's know this data. You have to first and foremost know the kind of
This is a
data. This
strange
data
data,
is a
you said.
is a string a categorical data. So basically, you
Normality
don't
on
run
string data.
normality test on it on string data.
Okay.
So what you usually
Okay.
do in place of normality, you run
Frequency.
frequency. You just run frequency, which you can also run descriptive statistic on. You know, if it's a continuous data, you run descriptives, but this one you run frequency. I don't know if you are getting the distinction now.
Yes, I'm getting it now.
Okay, so the first thing you do, you go to analyze. Now, you know, there's a step all of us, we've done transformation for this data already. We transform, we've coded and all of that. So the next thing now is for us to come now and yes, there's another step I also mentioned to us. I say if you look at this data, you see that this data is both cases, that is MDRO and non-MDR, which are the control. Then I want my result to actually come out groups in that order. I don't know if you are getting me. I want it to be grouped in that order. So what I need to do, I say you go to data. Are you with me? Then go to data, click on data, then you come to split data. Again, let me go over that again. You go to data, you go to split data, split file rather. Then I want my result to be to compare group. Then which group do I want it to by cases? That is a definition of subject, which is either cases or control. So you move that into this is what I did. Let me go over that again. You go to data, you go to split file, then you click on compare group, then you move your this is the one I want to move this definition based on cases or control as the case may be. So but this one is actually subject definition of subject rather. So you click on OK. So what this means is that all the output you are going to be having now, they are going to be grouped. So you come back here now, analyze, descriptive statistic, and click on frequency. Then for this, I want, I'll move all this other one here into the variable box. Then under statistic, we are not running anything here because they are not continuous. If it was continuous variable now, you can click out all this here. But because we are dealing with string data, we don't have anything. Then chat, we don't really, I don't think I want chat here. So all I just want is the frequency table. So just click on OK. So you can see the frequency table. Can you see why I say they should group it? Because I want everything to be in the same view. I don't want to first and foremost do for MDR, then I will not be the one bringing it together. No, I won't be able to really compare to see the visual to visualize the comparison rather. So this first table is actually like case summary, showing you there are missing data or not. Then the second one is the first aspect, which is contact with DROTB patient. Then under that contact with this DROTB patient, you know that, let me expand this. You know that basically it's a yes or a no question. So for MDROTB, the valid, those that said no was 61, which account for 89.7% of the total. Remembering that the total is 68. So those that say yes is 7, which accounted 10.3%. Then we move to the second aspect. No, sorry, the non-MDRO TB, all of them said no, that they didn't have. So automatically the yes will be 0, but it won't display that. But if you were reporting it on a normal study, what is expected is that you report the 0 to yes. Under here you have yes 0. So here will be 0, here will also be 0, and like that. So the second one is previous treatment. Now, for previous treatment, MDROTB, those that say yes, no rather was 33, while those that say yes was 35. So 48.5% said no, while 51.5% said yes. Now, if you look through here, for non-MDROTB, 65 said no, while 3 said yes. Now, even before we compare anything statistically, merely looking at this disparity in the percentage, for example, if you wanted to check if there's a statistical significance between if previous treatment was an impact on having DROTB, even without running any further statistics, this already showing, because out of all of them that developed multi-drug resistant TB, 51% of them had previous treatment of TB, while those that do not develop, just only minute, which is 4.1%, was the one that didn't develop, that had previous treatment but did not develop DROTB. So merely just looking at it visually, without even running statistics, see that there is a statistical differences between
no labeling.
Yes. So
So,
are you following?
Yes.
Yes.
So I was saying that we've not run any statistics. Now I'm just telling you that even merely looking at the percentage alone, you already know that previous treatment is actually a risk factor for developing multi-drug resistance, which is actually conventionally no, because someone, even I think that's why the issue of antimicrobial resistance is a big issue, because a whole lot of people will take on drug. The next time they will have encounter with that organism, the drug becomes resistance. So basically, then missed doses too. Looking at missed doses, those are said, yeah, that were previously under treatment, that missed doses. Out of all of them, 30%, sorry, which represents 5.9%, said they actually missed doses. So why those that do not have MDROTB said they didn't have any such at any point. So which is due to move for MDROTB, as the case may be for this. But we are still going to run statistics to be sure, to be able to conclude on that. Then the next one is cavity in the history of those exam TB. We can see that 54 and 54 of them, which represents 79.4, said no. Sorry, they didn't have there was no cavity in their X-ray result. Why 14, which represent 20.6%, shows that there was cavity for those that developed that had that have MDROTB. Why those that do not have MDROTB, for the 38 out of the the 68 individuals, we can see that 65, which represent 95.6%, showed no cavity. Why only 3, which represent 4.4%, had cavity. So also merely looking at this percentage alone, that also speak volume that actually there is an association between cavity and NDROTB. But those are just virtual looking at it and saying this is it. Then gene expert too. This I told us earlier that this particular gene expert result, there was, I think there's an issue with it because we can't have this same outcome. So we'll just leave this out. So we are going to run now. Once you've done this already, then the next thing that will come to mind for you to check. Remember, we said for you to all, and I want us to note that the Fisher exact test we spoke about, the goodness of fit, the chi-square, the Pearsman chi-square, all of them are types of chi-square. But what determines the kind of chi-square you will run, or the result you are going to take, is actually dependent on the numbers in each of the buses. Remember, I told us that if at any point in time, if any number in any of the buses is less than 5, automatically we are going to run what we call Fisher exact test. Is it the same way we are going to run the chi-square? We will run it, but there is a place here where the Pearsman, the Fisher exact result will be displayed. So in these cases now, merely looking at all of this, you can see that these are good category, because here we have 3 here. Then for here, we also have 3 here. So automatically for this and for this, we are going to be taking the Fisher exact result instead of the normal statistic. So how do you do this? You go to analyze, you go to descriptive, then you come to crossbar. Again, I go over that. You go through the PowerPoint I sent to us. You will see that there. You go to analyze, you click on the analyze, you click on analyze, you click on this descriptive statistic, then you click on the crossbar. So once you click on that, it will open up this. Now remember that what we are trying to okay, all what we want to do here is to move now. Before we do this, we need to go and switch off the, what's it called, this file, because what we want is the whole result now that we want. So we are going to reset this. Said okay. So for you to just switch it off, you reset it. So once you reset it, automatically it will change the setting. So again, you click on analyze, you go to click on descriptive, then you click on crossbar. Then you move your definition of subject to the row. Why this, and this? We'll move it to the colon aspect. So your dependent variable will be on the colon. Why all these other ones are the independent variable? They are the risk factors. Then you move them to the colon. Then under the exact test, we are not taking anything there. Then you click on statistics. Under the statistics, you click on this chi-square. Then you click on risks. Then you may also want to click on this McNema test. So you click on that too. Then we want to display cluster bar. Then under the cell, we want the percentage for colon, then total. So depending on how you may just say, okay, all you want is just the colon only, and you have that. So, but just for the sake of this test, I want to make this the three available for us. So click on OK. Under the format, there's no need to change anything there. So this suppress table, don't click. You only click on display cluster bar chart. So once you've done all those check, then you click on OK. So automatically, what happens? Okay, that stuff we did not work. So we need to go and we need to go back there again. Okay, go back to okay. So we have to go and off that because we didn't off it. That's why that's you can see the what he wrote. He said the variable definition is in use for split file, so it may not be used in cross tab command. Execution of this command stopped. So because we did not off it, so I've offed it. How did I off it? I go back there, I just click on file, then I click on this organize all cases, do not create group. Okay. So that off it. Then we went back to analyze, descriptive, cross tab, then everything is still intact. So click on OK. So now it's going to run our, you can see it has run our analysis for us. So now the first is usually case processing summary, as I mentioned earlier. So this second one is showing contact with DROTB patient. You can see just the normal way the other table, this initial table came out, is actually the same, but the only difference here is that we have percentage display here. So you can see here the zero I mentioned earlier, the zero here is now fully actually shown here. So you can see the percentage for each of this, same here. Then this is where the statistic is actually done, was carried out. Now you can see here, because what's it called? Because the here one of them is less than 0, so you can actually use the Pearson can use the Pearson chi-square, then, or better still, in this case, to be on the safer side, I usually prefer to use the likelihood ratio. Now, because we are looking at likelihood ratio is like the extent to which we have something. So since we are looking at, okay, to what extent will you have, for example, will you have TB in people that had contact with that had previous contact with patient with TB? It is actually 10 times more. 10 times more. It's actually 10 times more. It will be 10 times more in the in those that had contact compared to those that did not have contact from here. So in this case, the likelihood ratio will be what you will take. Then you take your this is your p-value, your two-sided p-value. But if you want to go for chi-square, for example, this is the chi-square, then this is the p-value. So then continuity correction, which is usually referred to as the Y-years correction test, but you hardly do not usually use that often. So now another thing too that you need to note here um, the risk estimate, which is usually the odd ratio. Now, because there was zero, the odd ratio only calculated for no. But what we need is actually for yes. So immediately, this is not, we can't use odd ratio here because that's why I prefer here to use the likelihood ratio, because it's almost telling me the same thing that the odd ratio would have told me. But because there was zero here, the odd ratio will not be available because you cannot calculate odd ratio for once zero is involved. So basically what you are picking from here, pick your likelihood ratio, pick your um what's it called, your p-value. Then if you chi-square you want to use, you pick the chi-square value. Then you pick um p-value. Then this degree of freedom is actually like how it's calculated is actually k minus 1. So k here mean the number of is usually k minus 1 bracket c minus 1. K is colon c is, sorry, k is row, y c is column. So in this case, once you have k is 2, because we have 2 column, then we have 2 rows. So k minus 1 is 2 minus 1 times colon, which is also 2 minus 1. So what I'm saying next, let me just bring this is what I'm saying. For you to get degree of freedom, which is df, is usually equals to bracket k minus 1 bracket c minus 1. So for this particular one now that we are doing, sorry, for this it will be 2, we have 2, remember we have 2 colon, so 2 minus 1 bracket 2 minus 1. So we have equals to, in this case we have equals to 1. So that was how the result was 1. So let's move to the next table. Now this is the chart. You can see the different charts here. So basically what this chart is just representing is actually just the numbers, not the percentage. So now the second one, this is the previous treatment. So you can see the distribution too. Then you can see the likelihood ratio, how big it is. So the likelihood ratio here, meaning that if you look at here, we are saying that there is 35 points, let's say 35 chance of having of people developing multi-drug resistant TB for those who were previously treated compared to those who were not. So you can see not 34, so it's 42.3, sorry, and the chi-square is 37. So in this case, you either use chi-square or you take the Pearson correlation. So that is that's for that. Same explanation. Then for this, because we have years, you can see the odd ratio for years is actually 11.667. Then this is the lower bound, then this is the upper bound. So if for example, if your supervisor has asked you to calculate the odd ratio, you add this is the odd ratio, then this is the 95% confidence interval, lower limit, then this is the upper limit. And these are the plots. Then the next one is doses. The same thing goes for that. So you can also see how high it is. You can see 67.8. So because there was no yes here to yes was 0, you can see that it equally did not showed anything. So for cavity too, you can see the percentage for cavity, the same thing. So basically, this is the odd ratio for yes. So it's the one that you are interested with, you will go the yes. So you come here and pick up the value for the yes. So that's actually how I did that last week. I don't know if is actually clear.
Yeah, it's getting clearer, but I'm very sure that we need to actually practice this
Yes.
to be able to we'll
So
try and
I'm
see.
going to also I will try and send. I will also send this data across so that
Yeah,
you will also lay your hand on it and practice. So basically that's where I want us to just stop the class today because of these other guys that are quite busy and also the other person that wasn't able to join. So hopefully we should dive into analysis of continuous data tomorrow.
okay.
So I'm going to send those two data now, so you guys will just play with it and let's see what you guys can come up with it.
Okay.
So Ify,
Thank
are
you.
you here?
Yes, I'm here.
Okay.
If
So
this is your voice,
Thank you.
all right. So see you guys tomorrow.
All right.
See
Thank you,
you
sir.
tomorrow.
All
Thank
right.
you.